Alright, today we're going to do number 11 from chapter 12. The question reads: a 15-meter uniform ladder weighing 500 newtons rests against a frictionless wall. So this line here, it represents our ladder and it has a length of 15 meters, and then this is our frictionless wall over here. The ladder makes a 60-degree angle with the horizontal, so here is the 60-degree angle. A reads: find the horizontal and vertical forces the ground exerts on the base of the ladder when an 800 Newton firefighter is 4 meters from the bottom. So here is our firefighter guy. He's 4 meters from the bottom of the ladder, and he exerts a force of 800 newtons downwards. Just for this problem, I just happen to make this way positive x and this way positive y. And so now we need to label the other forces. So at the top is the normal force exerted in the x direction by the top of the where the ladder contacts at the top of the wall. And then here is our frictional force done onto the ladder, like right here, because our ground has friction. And then here is our normal force in the y direction, also exerted by this spot. Okay, so it asks us, so now we are going to set up force equations. So let's do the y1 force. So the sum of all forces in the y direction equals the normal force in the y direction minus 500 newtons minus 800 newtons. And since the question doesn't say, but like the ladder's not slipping right now, so the sum of all forces in the y is going to be equal to 0. So the force in the y, the normal force in the y direction, is equal to 1300 newtons. And that is the first part of our answer to A. The second part, we sum up all the forces in the x direction, which is a little bit trickier. And we find that we only have 2, and we have the force of friction, and against that is the force, the normal force in the x direction. And again, this is equal to 0 because the ladder is not slipping. So frictional force is equal to normal force in the x direction. At this point, we can't solve it just relying on forces, so we're going to move on to using torque. So the sum of all torque equals, so our pivot point is at the bottom since that's our angle. Yeah, like I guess you could do it from the top, but it might make things trickier. So the sum of all forces is 500 newtons, and this point is exerted at the middle of the ladder, so 7.5 meters away, and it's at a length of cosine 60. And then also the 800 newtons of the firefighter times his distance, which is 4 meters, times, again, cosine 60 to represent this length, and then 7.5 meters times cosine 60 represents this length. And then this is minus the normal force in the x direction times, it's going to be 15 meters sine 60, because it's way up here, and so 15 meters sine 60 is this whole length down here. And again, this is going to be equal to 0 since the ladder is not slipping. He's just chilling on the ladder. And rearrange this, move this to the other side, and then divide by this portion, and you get F and X, the normal force in the X direction, is equal to 268 newtons. And you're not trying to find this, and actually this is gonna be, it's positive, but really it's negative in our scheme of things. But, well, actually it is positive, but the force in the frictional force due to the ladder, like rubbing up against the ground, so friction force, like we go up here, friction force is equal to the normal force in the X direction, so it is also 268 newtons, which is the second part of our answer to A. So here we have it in the X direction, here we have it in the Y direction. And moving on to B, the question reads, if the ladder is just on the verge of slipping when the firefighter is 9 meters up, what is the coefficient of static friction between the ladder and the ground? So what this means is the torque is still going to be, the sum of all torques is still going to be equal to 0. So that is how we are going to solve it, since it's on the verge of slipping, but it's not slipping yet. So it's basically the same equation, but a little bit different. So 500 newtons, 7.5 meters, cosine 60 here. So that's the ladder plus 800 newtons, and his distance has changed. It's 9 meters up, then again cosine 60, and then minus same thing, the normal force in the Y direction, and that's 15 meters sine 60. Okay, it's normal force in the X direction, sorry, it's right here. And this, this is equal to 0 since it's not slipping yet. You rearrange, and F and X is now equal to 421 newtons, and that is rounded. And this F and X is also equal to our frictional force, and we all know frictional force is U times normal force. So we have, rearranging, mu is equal to our frictional force, 421 newtons, over our normal force in the Y direction, so that's 1300 newtons, and solving this you get 0.32. And the reason you're using 1300 newtons is you're using the normal force in the Y direction, not the X direction.